Question 3 is about identification of the ions, how we can identify the ions. So it is important that you learn that table which I already shared with you. Solution Y and solution Z are analyzed. So we have two solutions. One we called solution Y, another one we called solution Z. Test on solution Y. So we are testing or carrying out a test on solution Y. Solution Y was divided into four portions. So what we did, like we took four different test tubes, and to each test tube, we add solution Y. So solution Y is added to four different test tubes. Test tube A, test tube B, C, and D, or 1, 2, 3, and 4. The first one, what we did, a strip or universal indicator is dipped. So we use a universal indicator and we identify that the paper turned blue. So when we are using a universal indicator and it paper turned blue, so it gives an idea that this is an alkaline solution. So this gives an idea that it is alkaline solution as the paper turned blue. The second part, to the second test tube, aqueous copper 2 sulfate is added. So we know this is alkaline solution because the first test indicate that this is an alkali. So this is an alkali or a base or a hydroxide here. This one is also an alkali. How we identify all the four test tube contain an alkali? Because test one indicate that when universal indicator is added, it shows a blue color, which shows that the alkaline solution. So all the alkalis are there. All the solution contain an alkali or alkaline solution. When we add copper 2 sulfate, a blue precipitate is formed. When aqueous copper 2 sulfate is added, so there is a blue precipitate. So what this gives an idea, this confirms the presence of a hydroxide ion, because when we add a copper salt here, a salt which contain a copper ion like copper sulfate, so as a result, when we add it form a blue PPT. So what is this blue PPT? It means this blue PPT is basically copper hydroxide, because the precipitate which are formed due to addition of alkali are hydroxide. So this, when copper sulfate salt is added to an alkali, it form a blue precipitate. So this confirms that there is a hydroxide ion present in this solution. And from the first test, it is obvious that it is an alkali. So there should be a hydroxide ion, as the universal indicator shows a blue color. Then in test 3, a flame test was done. And the third portion, we carried out a flame test and it gives a red flame. So which metal gives a red flame? You have to learn the flame colors, like lithium is there, sodium is there, potassium and copper flame. So lithium is red in color, sodium is yellow, potassium is lilac, and copper is green or blue. So this gives a red flame. So this confirms that there is lithium ion is present. So we identified this is an alkaline solution. So there is a hydroxide is present because it's an alkaline solution. And a flame test, we identify that lithium ion is also present. So what is this compound Y? What is this solution Y? So this solution Y is actually lithium hydroxide. So flame test indicate there is a lithium positive ion, and universal indicator indicate that it is an alkaline solution or hydroxide ion is there. So one test shows a lithium ion, another one shows the hydroxide ion. So basically the solution Y is a lithium hydroxide. And the test 4, dilute sulfuric acid was added to the fourth portion. No visible change, and test tube becomes slightly warmer. Like we add 2 cm cube of dilute sulfuric acid, H2SO4. We don't observe any change. Basically, acid and base are reacting with each other. And when acid react with a base, it will form salt and water. but it will form a soluble salt. That's why we don't observe any change here. But why the test tube becomes slightly warmer? Because the neutralization reaction, this is an acid, and this Y is lithium hydroxide. So acid plus alkali or lithium hydroxide plus sulfuric acid gives lithium sulfate plus water. So acid is reacting with an alkali, we call neutralization. And what is neutralization reaction? It is exothermic. That's why the test tube becomes slightly warmer. And why we don't observe any change, like no precipitate form or no solid form, because this lithium sulfate is a soluble salt. So when soluble salt is formed by mixing a two solutions, you don't observe anything. If it was an insoluble salt, then you will observe the precipitate. So it suggests the pH of solution Y. So how we can suggest the pH of solution Y? As you can see, the first test, that the universal indicator turned blue. So if universal indicator turned blue, it means it's an alkaline solution. So I can say it is having a pH 11 or 12 or 13. Normally, like 11 and 12 for blue, and then violet is there for 13, 14. So I can write any answer acceptable from 11 to 14, 11 to 13. Then identify solution Y. How we identify solution Y? This test indicate, because it's an alkaline solution, so this test indicate hydroxide ion is there, and a flame test indicate lithium ion is there. So there's a lithium ion and hydroxide ion. So what is solution Y? Solution Y is lithium hydroxide. 1 mark is for mentioning lithium, 1 mark is for mentioning hydroxide. And pH here you can mention, it can have a pH 11, 12, 13 till 14. But any one number you will mention, because they're not asking for range, they're asking suggest a pH, not a pH range. So in exam, don't write from 11 to 14, write a specific number. And why we are saying 11 to, because a universal indicator turned blue, so it means that solution is alkaline. Then we have another solution, solution Z is there. Solution Z is, they already mentioned it is a ammonium sulfate. So ammonium salt is there. So it contains ammonium ion and it contains sulfate ion. Complete the expected observation. We have to complete the observation according to the salt, which we know it is ammonium sulfate. Solution Z was divided into 3 test tubes. So we have 3 different test tubes which contain solution Z. And we already know it contains ammonium ion and it contains sulfate ion. The 2 ions which are present in the solution, one is ammonium, another one is sulfate. Five cm cube of dilute hydrochloric acid was added to a solution Z. So when we add hydrochloric acid, adding a hydrochloric acid and warm, if there is a sulfate ion, what is the observation? It will give a sulfur dioxide. Sorry, sulfite is there, ammonium sulfite. So if it's ammonium sulfite, sulfate is SO4, sulfite is NH4 in a bracket 2 SO3. Sulfite is SO3. So this is a test for sulfite ion. How we can test a sulfite ion? If we want to test, we add hydrochloric acid and then we warm. So as the result, when we warm, it gives off sulfur dioxide. The gas is given off. That gas is sulfur dioxide. And this sulfur dioxide convert acidified potassium manganate. This is an oxidizing agent, acidified potassium manganate. It will turn from purple to colorless. This is the test for this whole paragraph. What is written is actually a test for sulfite ion. So sulfite ion, if we want to test, we add hydrochloric acid, we warm the test tube, a gas is given off which is tested with acidified potassium manganate 7. It will turn from purple to colorless. Then name a gas being tested in C3. So which in C? So which gas is given off? The gas is sulfur dioxide. Then part E, an aqueous sodium hydroxide is added and the mixture is warmed. So this is a test for ammonium ion. What is the test for ammonium ion? We add sodium hydroxide, NaOH, and we warm. So there is a pungent gas is given off, which is actually ammonia gas. Result of, and then we warm and the gas is given off was tested. Result of a gas tested. So how we will test the presence of a sulfur dioxide? So we'll use a damp red litmus paper and it will turn blue. So there will be a damp red litmus because ammonia gas is given off, so it will turn blue. Identify the gas which is given off. So whenever ammonium ions are the ammonium salts are there, ammonium salts on addition of an alkali gives off ammonia gas. So that's why the gas which is given off is ammonia. Then about 1 cm cube of hydrochloric acid followed by barium nitrate. This is a test for what? This is a test for the ions such as sulfate. So this is a test for sulfate. But in the question, they already mentioned this is not ammonium sulfate, this is ammonium sulfide. Means it contains ammonium ion and it contains sulfite ion. So if we are testing for sulfate ion and it does not contain, so what will be the observation? There will be no visible change. Because why there is no visible change? Because the salt is not a sulfate salt, it is a sulfide salt. It is, as I mentioned in the beginning of the question, it is ammonium sulfide. So this is how you have this. The main important part of this question is you have to learn the test and observation for each of the positive and the negative ion. The table already I shared with you. The last question is always related to planning of the experiment. You have to plan an experiment. So as I mentioned here, tartrazine is used as a yellow food color. So we use a yellow food color. Plan an investigation to find out the yellow sweet containing tartrazine. Explain how your result will tell you if a sweet contain a tartrazine, and you have access to all the normal lab apparatus, the material, a yellow sweet and a sample of tartrazine. So we have a yellow sweet and we want to find whether this yellow sweet contain a sample of tartrazine. And you may draw a diagram. So whenever they say you should draw a diagram because maybe you missed any point in the explanation. So that will cover up from your drawing. So first what we do, we have a sweet, but we will use chromatography. And when we are using a chromatography, so for chromatography, we cannot put a solid, we should have a solution. So first we should have a solution of a sweet. So first we'll make a solution, then we'll use a chromatography. We'll draw the origin with pencil, and then we will place a sample of a yellow sweet. I'm writing as YS, yellow sweet, and a sample of tartrazine. So sample of tartrazine is there, that is T. Then how we will use, then we'll use a suitable solvent. As they did not mention, it is insoluble in water, so you can use a water as a solvent. Until unless in the question they mention it is insoluble in water, then you will use alcohol. So what we'll do, we'll dip this chromatogram using a suitable solvent. And what will happen on the chromatogram? The solvent will rise. And when the solvent will rise, the sample, like the yellow sweet and as well as the tartrazine, will also rise. If they rise to the same height, like if a level yellow sweet rises the same as the tartrazine, it means it is present in a yellow sweet. But what if the tartrazine does not rise to the same level? It means that tartrazine is not present in a yellow sweet. Because if there is a tartrazine is present in a yellow sweet, then the RF value of a tartrazine should be equal to RF value of the sweet. And should always be a label diagram whenever you draw, like here, chromatogram, solvent front, origin, solvent, sample. Now, what are the points we will include? The space is available. As you can see, this whole space is available, which is of 6 marks, the question. So what are the steps we will include? The first thing we will mention, we will use chromatography. That is the first point. When you mention use chromatography, you will score 1 mark. Then we will dissolve the sweet in the solvent to make extract of a sweet. We can use water. So first we dissolve yellow sweet in water. Then we will draw the origin on the chromatogram. By pencil. We never use pen or ink. Reason is that because ink will also dissolve in water, so it won't be suitable. So we'll draw the origin on chromatogram by using pencil. Then using a dropper, we'll place a sample of sweet and tartrazine on the origin. Dropper or a teeth pipette. Then what we will do, we will use a suitable solvent and let the solvent to rise to the top of the paper. We'll wait for a solvent to rise to the top of the paper, and then what we'll do, we can measure, we'll compare the height rise, the distance moved by the two spot, or we can measure the RF value. So any one of them, we can measure the RF value. If tartrazine has the same RF value as sweet, it means it is present. If it is having a different RF value than sweet, then it is not present. Or we can measure this vertical height, the distance moved by the yellow sweet and the distance moved by the tartrazine. If it is moving to a same level, same height, it means they are same. But if it does not rise to a same level, it means they are different. Like in a yellow sweet, the yellow color, food coloring, tartrazine is not present. So any one you can mention either height or RF value. So we can find RF value, or we can measure this height move or the distance move, basically measure the height rise or distance move. If RF value or if distance move are same, it means the yellow sweet contain tartrazine. So this is a simple 6 marks experiment in which you have to plan or identify that there is a sweet, yellow sweet, and there is a yellow food color. Whether a yellow food color is present in a sweet, you can use a chromatography to work out this experiment.